Welcome to the lecture series Programming in C. In this lecture, we will learn about the mathematical functions in C. So, we will focus on learning the header files and math.h header file, which is a specific header file for including or for using the functions with respect to mathematical functions, and types of mathematical functions which are supported by C language, and how the mathematical functions are being applied in a C program. So, header files are the one which consist of the function prototypes of all the library functions which are required for doing certain tasks with respect to the particular operations. There are different types of library files which are meant for handling different purposes. So, out of which we will be focusing on learning the header file math.h. So, for instance, here we can see stdio.h is a header file which handles standard input and output operations with respect to the input output library functions. Math.h is a mathematical library function set which is available in the header file math.h. stdlib stands for standard library. So, which has the function prototypes for converting numbers to text, text to numbers, and memory operations, random number generations, and other utility functions with respect to standard library. And time.h is the header file related to specifically handle the time and date related operations. ctype.h is a header file which has the functions with respect to characters, and it is used for converting from one character, one case to the other case. Such kind of functions we can see in ctype.h header file. And string.h header file completely deals with the string manipulation functions. So, likewise we can use the header files with respect to the corresponding library functions which we want to use it in our program. So, an example of using the library files, how we can use a library files in our code, it is by using the hash include preprocessor directive. So, hash include is a preprocessor directive which will support us include or add the library functions of the corresponding header files. Say for instance, if I want to use input output relations, input output operations related header file, I can just use it as hash include stdio.h. So, this will allow us to use the input output functions like scanf and printf. Henceforth, I can make use of the function scanf, I can make use of the function printf in case if I am using the header file stdio.h. If I am using the header file stdlib.h, which will allow the process related functions to be used. So, for instance, exit is a function which is the prototype of which is available with stdlib. And math.h is a mathematical library functions. So, one of that is sqrt, meant for calculating the square root of a given number. So, math.h is a header file dealing with all mathematical operations. So, sqrt, when I want to find out the square root of a given value, I may have to include the header file math.h. So, these are the header files usage in our program. In case if we want to use the built-in functions, we have to make use of the built-in functions in our program, and for that we need the support of the header files. So, in this lecture we will specifically focus on learning more about the math header file, interestingly which includes all mathematical operations, starting from finding out the square root, finding out the power, finding out the seal value, floor value, remainder of a division. So, all these functions are equipped with math.h header file. So, we will learn the functions one by one. So, the function categories, the mathematical function categories are classified into 5 major types called trigonometric functions, hyperbolic functions, exponential and logarithmic functions, power functions, rounding, absolute and remainder functions. So, the corresponding functions with respect to each category, it is tabulated in the screen. The trigonometric functions includes cos, sin, tan, a cos, a sin, a tan 2 and sin h, cos h, tan h are the hyperbolic functions. exp, that is exponential, logarithmic functions, log 10 with respect to base 10, and sqrt and pow are power functions. Then the absolute, rounding, finding out the remainder. So, those categories are again classified as a different category with floor, seal, ABS and mod functions. So, the example usage of each function, it is tabulated here. SQRT of x, provided x should be a floating point type value. In case if we give it as SQRT of 900.0, we will be able to get the square root of its value. SQRT of 9.0, we will get the square root of it, which is 3.0. So, likewise, if at all we want to find out the cube root of a value, we can make use of CBRT function. EXP, exponential, e power x, in case if I want to find out e power 1, that is e power 1.0, I can make use of the EXP function. In case if I want to find the log value of a given number, I can make use of the function log, the logarithmic value, the natural logarithmic value with respect to base x, base e, we will be able to get it. And log 10 will allow us to get the logarithmic value with respect to base 10. So, log 10 of 1.0. So, likewise I can make use of the log 10 function for finding out the logarithmic value of a given x value with respect to base 10. FABS is a function which will allow us to get the absolute value of floating point number, and seal of x, which is a rounding function which will round the x to its smallest integer not less than x. Floor is again one more rounding function in which you can give the floating point value as the input, and this will round it to the largest integer not greater than x. POW is a function which will help us find the power of two given integers, that is 2 power 7. In case if I want to find out 2 power 7, 2 and 7 should be given as input for the function POW, and POW 9 comma 0.5 will allow us to find the value 9 power 0.5, which is again a square root. F mod function will allow us to get the remainder of a division. So, generally we will be able to get the quotient value on a division by just applying the slash operator, but then for finding out the remainder of a division, we can make use of the function f mod. Sin x, cos x and tan x, all these three are trigonometric function helpful for us to find the sine, cosine and tangent values of a given floating point number in radians. The given input should be in radians. In case if it is going to be a degree, the degree has to be converted to its corresponding radians value, and then it should be given as input to find its sine, cosine and tangent values. So, let us see the function operations one by one, and we will also learn how to make use of those functions for finding its mathematical output. So, sine function, if we take the sine function, that will help us calculate the sine of a given angle in radians. So, it returns the sine of a given angle which is a value between -1 and +1. So, how we are supposed to give the value as input. So, the syntax of it double sine of double x. It means that x should be of double type, the input should be given in the form of radians. So, the output will range between -1 and 1, which is going to be the sine value. So, on example of using the sine value, let us find out the angle in radians. So, for finding out the angle in radians, we will be using the pi value divided by 6, okay, and that will give the value in degrees, 30 degrees. So, if I want to find 30 degrees, I need to first convert that to the degree in radians, and then I have to give that as an input to the sine function to find out the value of sine 30. So, the output will be sine value of 0.52 radians, it is 0.5. So, sine 30, the result will be 0.5. A cos function is used to calculate the arc sine, that is inverse cosine of a given number. So, the syntax of the function, it is also same as the sine function. The only thing is the function name should be given as a cos. The value which we are specifying in x, whose arc sine is to be computed, it should be in the range -1, 1 minus 1, 1 minus 1 and the range should be between -1, 1 to 1, 1 to 1 and then 1. Because the cosine values outside this range are considered to be invalid values. It returns the value which is going to be in the range 0 to pi, that is 0 to 3.14. So, we will see an example of applying a cos function. So, we need to define a double type variable whose input should be given to the a cos function. So, one thing to be noted in this case is, if x is outside the range -1, the given range, a cos will return a n, which is a not a number, and it will set the error number to domain error. It means that it will be considered as an invalid value, that is the value which is out of its range. In order to get the result in degrees instead of radians, we can convert it by multiplying as usual 180 by pi. A sine function will help us get the inverse of sine, which is arc sine. So, the syntax is similar to the sine function, we will just use it as a sine. So, the range is very similar to a cos function, and the arc sine of x will be in radians. So, the result will be in the range minus pi by 2 to pi by 2. So, this is a way that the a sine function can be used in a program. So, we need to define a variable of type double and then give that as input to the a sine function. So, which will result in the reverse of the sine value or the arc sine value. Then sin h is a hyperbolic sine function which is used to get the sin h value. So, the only thing that differs in syntactically is the sin h function, the function name, and the parameter should be given in radians, and it calculates the gives a result as the hyperbolic sine or sin h value. So, this is the way it can be used in a program. So, double is the value is defined in double data type, and we can make use of the function sin h. So, that the result will be the hyperbolic sine value of a given number. So, the result or the output is given to be the hyperbolic sine of 1 is the result is 1.18. Then arc tangent or the inverse tangent of a given number. So, this you will be able to again make use of the same syntax as double a tan double x. It means that the input should be also a double type, and we can make use of the values from the range as given in the A tan. The result will be the arctangent of x in radians which will be in the range minus pi by 2 to pi by 2. So, this is the way it can be used in a program. So, define a double type variable and give that as input to the A tan function, which will result in the inverse of the tan or the arctangent function. And there is A tan 2 function, it is also used for calculating arctangent of y by x, while taking into account the signs of both y and x to determine the correct quadrant of the angle. This is how this A tan 2 function is different from tan function. So, it takes two arguments. So, here we can see the syntax that A tan 2 is different from A tan function in the number of arguments. So, here we need to give both x and y coordinate as the input. So, the result will be in the range minus pi to pi. So, in what way it is different from A tan function? A tan 2 returns values in 4 quadrants, ensuring the angle correctly reflects the position of the point x comma y. If x equal to 0, then A tan 2 will return pi by 2. If y is greater than 0 and minus pi by 2, if y is less than 0. So, we can see a small example given here. So, we can define the y value to be with the value 1.0, x value is also of double type. So, which represents the coordinates y coordinate and x coordinate. So, while giving the input to the A tan 2 function, y coordinate should be given and then x coordinate should be given as input. So, this will result in the arctangent of the given value y. So, tan function will just give the tangent value of a given input in radians. So, the syntax is double tan double x. So, the double type value should be given as input and it calculates the tangent value of the given x. The value or the result will range from minus infinite to plus infinite. So, this is the way it can be used in a program. So, the double type angle should be given as input. So, if it is going to be a 45 degrees in radians, tan 45 is going to get the result as number 1. So, obviously, the tan angle will calculate the tangent of the given number, given degree it is 45 degrees. So, tan 45 will result in 1.0. Tan h function will calculate the hyperbolic tangent of a given number, that is tan h. The syntax is the same as tan function, double tan h function. So, the value again should be given in radians. It results in the hyperbolic tangent of a given double value. So, the result will be ranging from minus 1 to 1. So, we will see how it can be used in a program. So, define a double type variable and assign the double type value 1.0 to the variable, and this is a way that the tan h function can be used and the result can be displayed. Since it is a floating point value, the result is a floating point value, we can make use of the control strings f for getting the result displayed in the form of a floating point value. So, the result will be hyperbolic tangent value, and cos function will help us calculate the cosine of an angle whose value will be between minus 1 and 1. So, again the input has to be given in the form of radians. So, we need to convert the degrees to radians and then the input can be given in the form of the radians. So, here we can see a small example of declaring the double type variable angle with the value 1.0, and the result can be computed by applying the cos function to the variable. So, the result will be the cosine value. Cos h function will help us calculate the hyperbolic cosine of a given number. So, the syntax is going to be the same as the resultant is going to be a double type value, the input is also going to be a double type value. So, as in the same the other hyperbolic functions like sin h and tan h. So, here also we can give the input in the form of radians and the output will be in the range 1 to infinite for non-negative x value. So, this is a way it can be used in the program. So, be careful on declaring a double type variable and that variable has to be passed as input for the cos h function to get the hyperbolic cosine value. Then coming to the absolute and rounding functions, we will be focusing on ceil floor functions. So, it is ceil function, it is used to round a floating point number up to the nearest integer regardless of whether it is positive or negative. So, this function will help us find the smallest integer value that is greater than or equal to a given number. So, this will actually allow us to do the rounding process. So, here I declare a variable named value 1 with the value 3.14. Also, we are declaring a variable value 2 with a value minus 3.14. So, if I apply ceil function for value 1 and ceil function for value 2, ceil function for value 1 it is a positive value, the ceil function for value 2 it is a negative value. So, if you are rounding up, the positive value is rounded to the next higher integer and the negative value will be rounded again to the next higher integer, but since it is a negative value we will be getting the lower value of the integer given. So, we will be getting it as minus 3.0. Floor function, it is actually the reverse process of ceil function. It is used to round a floating point number down to the nearest integer regardless of whether it is positive or negative. So, the same way the floor function can also be used on a double type input. So, here we can see a small example as in the ceil function. So, here also we use two values of double type 3.14 and the negative minus 3.14. If I apply floor function for value 1 and value 2, the result will be 3.14 will be rounded to its lower integer which is 3.00 and since it is a negative value, even if it is going to be rounded to its lower value, the value will be minus 4. F mod function will allow us to get the remainder of a division. So, which requires two operands of double type again, the dividend and the divisor. The divisor should always be a non-zero value. We are not supposed to give 0 as the second argument for an F mod function, because if we try to divide a numerical value by 0, this will result in infinite value which cannot be handled by the compiler. So, we are not supposed to give the divisor to be a 0 value. So, divisor should always be a non-zero value. So, in this program we can see that x value is assigned with value 5.3, y value is assigned with value 2.0. So, if I want to find the remainder of the division between 5.3 and 2.0, we will assume that 5.3 to be the dividend and y 2.0 to be the divisor. So, it satisfies the condition that the divisor should be a non-zero value. Henceforth, we can make use of F mod function and we can allow the remainder to be calculated and we will get the remainder of the division as 1.30. Then coming to the category of logarithmic functions, we can make use of log base e, that is natural logarithmic value by applying log for a double type variable. So, this calculates the natural logarithm and it must be a positive, that is greater than 0 value. So, this is how a log function can be used for a double type variable. So, very easily we will be able to calculate the log value. We need not go for depending on the logarithmic table to find out the log base e value. So, very simply we can make use of the log function, and if we give the whatever be the larger input, you will be able to calculate the log value very easily. And log 10 function will help us calculate the logarithm base 10 value of a given number. So, the number should be a double type number. So, we will be able to calculate the log with respect to base 10 logarithm. So, base 10 logarithm of x will also be a double. If x is less than or equal to 0, log 10 will return a huge value. So, this will result in an error. So, this is the way we can apply log 10 to a double type variable. POW is a function which will help us calculate the power of a given number. So, we can see here that the parameters should be both double type, the base and the exponent. So, for what base you want to calculate the power of what value. So, both should be given as input, and here we can see how it is applied in a program. So, if I want to find out 2 power 0 power 3.0. So, we will be able to give the values as 2.0 here, 3.0 here, which will result in 8 actually. And round function will help us just round the floating point number to the next nearest integer. So, this is the way we can make use of the round function. Value 1 2.3, it is rounded to 2.0. 2.5, it is rounded to 3.0 because the decimal part is 0.5. Minus 2.5, it is rounded to minus 3.0. So, the general mathematical round operation, if we want to use, we can make use of the round function. And we have also seen the SQRT function, which is used for calculating the square root of a given double type value. So, 16.0, apply SQRT for 16.0, we will get the output as 4.0. Remember, whatever be the mathematical function we use, do not forget to include math.h, otherwise it will not work. So, on summarizing the mathematical functions in this lecture, we are now learnt about the importance of header files and what the prototypes that the header files will consist of, and what for the header files are simply useful for using the built-in function. And we have focused much on math header file, which has a lot of mathematical operations functions to be held up with a math.h header file. So, we have seen the types of mathematical functions as trigonometric functions, sine, cosine, tangent, and also arc cosine, arc sine and arc tangent, and the hyperbolic functions sin h, cos h and tan h. Also we have seen atan and atan 2 functions. Then exponential calculation we have seen using ESP function. Logarithmic function we have seen 2 logarithmic function with respect to base e, that is natural logarithm using log, and the base 10 using log 10 function. And power function we have seen POW, how we can calculate the power of one double value to the other. Also we have seen rounding functions, round, seal and floor functions, and how it can be applied in a C program. And absolute is used for calculating, ABS is used for calculating the absolute value of a given floating point value. Also we have seen the F mod function to calculate the remainder of a division. So, on learning all these mathematical operations functions, how it can be applied using a C program, we have now learnt that how to make use of a scientific application can be brought into C program. So, it is an interesting session to learn about the mathematical functions, and hope you might have learnt about, you might have understood the mathematical functions and how it can be applied in a C program. Thank you.